Hello and welcome. What I'd like to do here for a couple minutes is to talk about decimal to binary conversion, which we need to know how to do in IPv4, in IP in general, or in computing networking in general. So what we have here are the bits, the octets, 1, 2, 3, 4, 5, 6, 7, 8. Each of these bits has a value. And these values are based upon the placeholder. And it's 2 to the power. And if you notice that, since it's binary, that each time we just double it. We start with 1, 2, 2, 4, 8, 16, 32, 64, 128. I guess I better turn my pen on. And maybe that will work. I won't be moving these things. But each one of them doubles. That also has some implications in security. Each bit that you add for encryption, for instance, doubles the power of it. So these things are doubled each time, starting with 1, and 1 because 2 to the 0 power is equal to 1, and this is just the bit number, the number of bits in each of these things. If we add all of these things up, 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, we're going to get 255, which is our 256 numbers. 0 through 255 is 256. Remember, in networking, 0 represents something. So each of these bits can have a value of a 0 or a 1. If it's turned on, it's going to be a 1. If it's a 0, obviously it's going to be a 0. So in this first bit can be a 0 or a 1. So we can have a 0 here, and then the next one we can have a 0, 0, 0, 1, 1, 0, or 1, 1. When we look at these things, 0, 0 obviously equals 0, equal 1, equals 2, and this is going to be equal to 3 because it's equal to 2 plus 1. Okay, so let's look at some numbers. Let's get rid of those and get back to the pen. So let's say we had a number like 155, and I'm just making these things up. If we want to find out what it is in binary, my easy way is using the subtraction method. We go to this table up here and say, in 155, are there any 128s? Yes, there is one. And so we subtract 128 from it. That's going to be what? 7, 4, 27. Are there any 64s? No. Are there any 32s? No. Are there any 16s? Yep, there's one 16. 1, 1. Does that sound right? Is there any 8s and 11? Yes, there's 1. 8, and we subtract 8 from that, we get 3. Are there any 4s? No. Are there any 2s? Yep, there's 1. We'll just keep going in a 1. So that should be the binary representation of 155. If we add those up, let's see if I made a mistake. 128 plus 16 plus 8 plus 2 plus 1. And just doing one of the, for me, idiot checks is it's an odd number, and I have a 1 here, so it's going to be an odd number. If I have a 1 here, if I have a 0 here, it's going to be an even number. So 8 and 6 is 14, right? And 8, 22, 23, 24, 25. Carry the 2. 2 and 2 is 4, 5, 155. So quick and easy decimal to binary conversion using the subtraction method. With that, I'm going to quit here, and I want to thank you for watching, and I hope this has been useful.